this video, I will be explaining the rate law, rate constant, and order of an elementary reaction, and how each of these affect the frequency and success of molecular collisions. I will utilize 3D models, mathematical concepts, and connect it to the real world. Let's start off with a very simple bimolecular elementary reaction. Just to recall, an elementary reaction is one in which molecules collide in one step to form a transition state, then a product. Unimolecular, bimolecular, and trimolecular described how many molecules actually collide. Since this is an elementary reaction, its rate law can be written based off of its equation, such that the coefficients are the molecule's order. Now, the order of the reaction explains how exactly a change in concentration would affect the reaction rate. The overall order of the reaction would be 2, and if we were to double the concentration of CO, the reaction rate would also double, likewise for NO3. As there are more molecules to collide, there are going to be more collisions, and thus the reaction rate is able to increase. But what is this whole thing about K that we have been ignoring? The rate constant K is able to describe some of the key factors that affect the reaction rate. Seen by the Arrhenius equation, not all molecular collisions react successfully, and the rate constant is able to account for this. The value A describes the frequency at which molecules collide in the correct orientation. The activation energy describes the energy needed for a reaction to occur, and T refers to the temperature of the system. E and R are simply constants. Let's analyze this further. If the value of T is high, there is more energy in the system, and the fraction of particles with enough energy to successfully react increases. Thus, there would be a larger value of K and a greater reaction rate. If the activation energy is low, reactions do not need as much energy to occur, thus making the value of K and the reaction rate also larger. If the value of A is large, there are more molecules colliding in the correct orientation, causing K to increase and also the reaction rate. This concept can also be applied in industry, such as producing materials faster, and is also the reason why cookies bake faster at higher temperatures. So let me turn up that heat, and I will see you later.